The stars begin curving before the object appears.
That is the part the reconstruction keeps failing to normalize. Light near the edge of the frame shifts first. Then the dark mass enters view afterward, as though the surrounding space detected it before the camera did. A planet larger than Jupiter drifts between stars with no visible system attached to it. Your eyes keep waiting for a sun to enter frame. Nothing does. The background keeps behaving like gravity is present anyway. At first, it looks like damaged footage. A section of the star field near the center of the frame begins to warp slightly, as if the image itself is pulling sideways. Tiny points of light stretch for a fraction of a second, then slide back into place. One star curves around something that is not visible yet. The background should stay fixed. One section folds inward anyway. A black shape moves slowly across the stars after the distortion is already happening. No glow, no reflected light, just a dark, circular absence crossing open space far from any visible system. A rogue planet larger than Jupiter crosses empty space. There is no star. Your eyes keep searching for one anyway. A planet is supposed to orbit inside a system, reflect light from something nearby, but the stars around it keep curving along the edge as the object drifts between systems. One point of light bends sharply, disappears behind the darkness, then reappears on the other side. The region around it no longer behaves like empty space. The distortion starts before the planet enters frame. The stars begin shifting before the object is fully visible. The empty space already behaves differently before the object becomes visible at all. And if something this massive can cross interstellar space alone, then empty space is not as empty as it looks. The next pass catches it again by accident. A distant star near the edge of the frame brightens for less than a second. Not enough to look important at first. Then the point of light stretches into a thin arc, curves sideways, and snaps back into place. The image freezes for review. By the time the background stabilizes, the object causing it is already gone. The rogue planet only becomes visible when something behind it bends. That changes what observation even means. It does not appear as an object first. It appears as a mistake in the background. The distortion is the only proof it passed through the frame at all. Then it is gone again. The region looks empty again almost immediately. It keeps drifting through interstellar darkness, massive enough to bend light while giving almost none back. Tracking starts depending on alignment. A distant star crossing behind it at exactly the right moment. And that means most of the time, there may be nothing to see at all. One object crossing unseen between stars is already difficult enough. But once the image proves a world this large can cross between stars without announcing itself, the question spreads outward very fast. Not where it is. How many never pass in front of anything bright enough to reveal them?
Surveying the vastness of interstellar
The reconstruction
space,
finally makes the motion look
most
physical.
rogue planets may never be seen at all.
A simulation rebuilds a young star system crowded with giant forming planets. Massive planets cut across unstable orbits. One drifts inward, another gets pushed wide. Then one of them swings too close to the others and gets thrown free. The giant planet slingshots out of the system. Its path straightens away from the star, past the remaining planets, and out into interstellar space, where nothing slows it down again. For a moment, the distortion events stop feeling impossible. Jupiter-mass planets already dominate nearby orbits, while systems are forming. Violent ejections fit the behavior. The trajectory finally looks predictable. The distortion events finally seem attached to a believable history. That explanation works. But only for the exit. The model explains where the object came from. It does not explain what happens after millions of years moving through open space with nothing nearby to absorb its influence.
The path explains the departure, not the consequence.
And that distinction matters, because explaining the ejection does not make the object any easier to track now.
The projected path keeps extending outward across the screen. The original star system shrinks behind it, reduced to a distant point the model barely highlights anymore. The ejection sequence finishes. The orbit lines stabilize. The reconstruction closes the orbit lines and moves on.
But the distortion field keeps moving with it.
It crosses interstellar darkness, carrying the same gravitational pull that bent the earlier star field. No sunlight marks the edges. No nearby star defines a system around it. There is no visible boundary where the effect starts. It keeps affecting space around it long after the star system disappears behind it. The simulation stops looking contained. The rogue planet is not just material thrown out of a collapsing system. The starless giant keeps carrying gravity forward long after the original system stops mattering at all. That is where the earlier confidence starts breaking apart. If the ejection explains the object completely, the danger should fade once the system is left behind. Instead, the isolation becomes the dangerous part. No nearby star marks where its influence ends. The mass just keeps moving through open space, affecting regions that still appear empty. The model no longer feels like a map of where the planet is going. It starts looking less like a trajectory and more like a moving region of distorted space. The image darkens again until almost nothing remains except distant stars and the corrected trajectory line moving through them. Then the object disappears completely. Only the background keeps changing. One final star near the edge of the frame bends slightly sideways after the planet is already gone from view. The distortion lasts less than a moment. Then the light straightens again, and the region returns to looking empty. But the frame no longer behaves like empty space. The object leaves the frame before its effects do. The projected path still breaks into uncertainty once the object moves beyond direct observation. The object can be reconstructed and traced backward through the simulation. None of that makes it visible in any reliable way once the darkness closes around it again. The explanation improves prediction without restoring control. The final answer explains what it is without restoring any real sense of control. A planet does not need a sky. The opening distortion means something different now. A Jupiter-sized world can exist between stars almost completely detached from the systems that normally make planets feel familiar. There is no sunlight or surrounding structure around it. The only warning is what happens to the light behind it. The empty space at the beginning was never truly empty. It only looked empty because the mind expects massive things to announce themselves somehow.